Hi, this is Paul again, and I've got another video to show you, and I'm calling this close packing geometry for protein. In the last few years, I've put a lot of research into a system I called CubicWonder. Let's take a look. Now in front you can see I show 8 Bucky cubes in a 8 cube arrangement. Now these are integrated geometry and it's very interesting. Now what I'm going to do now is to take 4 Bucky cubes away, and then I can show you the integrated geometry of a Plato cube in the center. I'm also showing 2 red outlines of Bucky cubes, and you can see by this that 2 Bucky and 1 Plato in the center forms a vertical string. Okay, we'll start by showing this with a Plato in the center and 2 Bucky outlines in a string. And then we can show the Bucky cubes and the Plato cubes all together in a perfect string with showing all the colors. Now if you study this geometry, this string can go from corner to corner of the Plato cube in 4 different ways, but I'm not showing them right now. Okay, the next step is to whittle down the pieces of the Plato cube down to the center octahedron. Now if you study this geometry, you can see that that octahedron can fit onto the 8 corners of the Bucky cube, the top one and the bottom one. This is what we call close packing. Now my next step is to take the corner pieces of the Bucky cube away and leave them axions. This is a name given by Buckminster Fuller. It is also called a cube octahedron. This geometry in front was also described by Keith Critchlow in his book called Order in Space. But I guess the work of Keith Critchlow has been given the cold shoulder. They prefer chaos and working in 2 dimension. I guess when a person is very important, he doesn't have to work in 3 dimension. He can take the easy route, because important people just has to work with equations and look at numbers. They don't have to get into 3D geometry. Anyways, I think we've come to the end of this part where we go from CubicWonder to cube octahedron and octahedron. Okay, the next stage is to go back to the outlines only for this. First of all, we're going to move this to a position to show you the linkages. Okay, now I'm going to show you how the cube octahedron and octahedron can form a 3-dimensional string, just like protein. Okay, in front I'm showing you a yellow string going from the centers of each of the entities. This is just a theory of mine, but it shows how the strings of protein can go together. Okay, the next part of the protein geometry are the swirls, the strings of swirls. Now what I found is that the swirls comes out of the geometry of the cubes, the Plato and Bucky cube strings. Now this gives the swirls a bigger diameter than the Dymaxion strings. And I showed this in my other video that I made earlier on about alpha swirls, Alphy swirls, 3D printed Alphy swirls. I'll give you a glimpse of these Alphy swirls rotating. and you can see that the length of the swirls depend on the length of strings of cubes. Okay, now I'm going to show you this in the top view, and you can see the difference in diameter between the cube outline and the Dymaxion outline. You can see the greater diameter. Now I've got something interesting to show you. I am showing you a longer Alfie swirl, the yellow swirl, and I'm showing you a cyan swirl, and you can see how they go perfectly together. Isn't it amazing? I think there might be some scholar out there that can see how CubicWonder could give us the geometry for protein, because up to now I've had zero interest in any of CubicWonder for the last 16 years. Anyways, I think I'm going to call it a day now. So this is Paul saying thank you very much for watching my video.